Okay, so here's part 2 of your Unit 7 review. Fill in the table for the linear function y equals 4x minus 2. So when x is negative 3, I put negative 3 in place of x. 4 times negative 3 is negative 12, minus 2 is negative 14. And I could keep on doing this. Or you could get your calculator, go to y equals, clear that, type in y equals 4x minus 2, and go to your table of values. That's using the second key with your graph. And now I go to where x is negative 3, and I realized I was right. It's negative 14. Well, when y is 2, my x value is 1. When x is 5, my y value is 18. And when my y value is 26, my x value is 7. And the calculator is going to help you out a lot with that. Okay, next up, number 10, graph this equation using a table of values. So I first make sure that my y is by itself, and I'm really not going to use this. I take a look and I see that this is a fraction. So when this is a fraction, I want to use multiples of the denominator. I want to have numbers that 3 can go into easily. So negative 6, negative 3, 0, 3, and 6 would be good ones. All right, let's go to your calculator, clear this, get your fraction, alpha y equals, we're going to look at 1/3, so 1, 3, 1/3 x plus 2. Let's get your table of values, second graph, and when x is negative 6, we see that y is 0. And then we see a whole bunch of fractions for y, but that's okay because our next multiple of the denominator, negative 3, will give us an integer value for y, which is 1. And then we go down to where x is 0, and our y value is 2. We go to where x is 3, and our y value is 3. And finally, when x is 6, our y value is 4. So to graph, we make sure to label our axes. Y is with the long tail, the vertical line. X is this axis. I always start at the origin. So negative 6, 0, I go 6 to the left. 0 means I do not go up or down, so I'm going to have a dot there. Start at the origin again. Negative 3, I go 3 boxes to the left and 1 box up since that's a positive one. Start at the origin. 0 means I do not go left or right. 2 means I go straight up 2 boxes. Start at the origin. 3 to the right and 3 up. And then start at the origin. 6 to the right and 4 up. Okay, you're going to grab your straight edge or your ruler. We're going to make one straight line that extends all the way across this plane. We put arrows to show it goes on forever, and we write the inequality, the equation right on that. Okay, and we already have this in our calculator, so let's press graph. And let's make sure it matches what we just graphed, which it did. Okay, next up, does this point lie on this graph? So we're going to say this x value is 36, the y value is negative 5. Our plan is let's substitute that point into the equation, and let's see if it makes the equation true. So does it make the equation true? If it does, the point lies on the graph. If it does not make the equation true, it does not lie on the graph. So this should have said y. In place of y, I put negative 5. 5/6 times 36 minus 35. So we have negative 5 equals, and 5 6 of 36. 6 goes in this 1. 6 goes in 6 times, that's 30, minus 35. We have negative 5 equals negative 5. Yes, since it made it true, the point does lie on the graph. If this was a little tricky for you, remember, you can quit out of this and just type this right in. Alpha y equals, get our fraction, 5 6 times 36 minus 35. And that tells us that would be negative 5. Okay, let's take a look at page 33. We need to graph this using the slope-intercept form. So we look at the side that has y, and we need to get everything away from y. So let's add 12x first. Addition, property of equality. We have 3y equals 12x minus 6. Remember, these are not like terms, and we write the variable first. Instead of multiplying by 3, we're going to divide each of these by 3. And we get y equals 4x minus 2. Our slope is the coefficient of x. It's 4. Since we're going to graph with it, we need to make it a fraction, 4 over 1. The y-intercept is the constant, which is a negative 2. All right, we're ready to graph. So here's y and x. I begin at my y-intercept, and my slope is how I move. So I begin on the y-axis at negative 2. To move, on top is how I move along the y-axis. Since it's positive, I'm going to go up. The 1 on the bottom is how I move in the x-axis. I move left or right. Since it's positive, I go to the right. So up 4, to the right 1, up 4, to the right 1. You take your ruler. We make an arrow, a line with an arrow all the way across the graph, the coordinate plane. And you write the equation. I usually write the original one. If you write the y equals, that should be fine. All right, this one you could graph using any method. Whoops. Let's go back to this, guys. Let's double check in our calculator. So y equals, we're going to clear that. We're going to put in 4x minus 2. And let's make sure our graph looks like this, which it does. So we know we did it correctly. All right, let's graph this using any method. So what if I was going to say slope y-intercept? Y is by itself, so my slope is going to be the number in front of x, 3. Let's make it a fraction over 1. The y-intercept is my constant, negative 4. I'm going to label my axes. This is y and x. This is where I begin, and this is how I move. So I begin at negative 4 on the y-axis. The positive 3 here means I move up, and the positive 1 on the bottom, I move to the right. So I move up 3, 1 to the right, put a dot. Up 3, 1 to the right, put a dot. Up 3, 1 to the right, put a dot. I connect that. I make sure I put arrows at the end to show what goes on forever. And I write my original equation on the graph. You could have said, you know what? I want to use my table of values. I'm going to get some points for x and y. So I'm going to erase this, put in y equals 3x minus 4, and look at our table of values, second graph. And since this is an integer, we usually pick the integer values, negative 2, negative 1, 0, 1, 2 for x. So negative 2 would be negative 10. I can write that here, but that's going to be too low for this. So I'm not going to graph that. Negative 1, negative 7, that still might be a little bit tricky. 0 goes with 4. 1, negative 1. 2, 2. And I might add, you know what, 3, 5 would be easy to graph. And look what happens. 0, did I put this? Oh, this was a -4. 0, -4 is here. And 1, -1 is here. And 2, +2 is here. And 3, 5 is here. So whether you did it with slope-intercept or a table of values, we would still have gotten that same line. Okay, let's look at 34, our last question. Graph and label. This one can be quick. We're going to label this y and x. If y is equal to a number, I go to that number on the y-axis, I put a dot, and I draw a horizontal line right through it. And I put arrows, and I write my equation. Remember, we can also check this on your calculator. Let's clear that. Just type in -1, press graph, and it looks exactly like the one that we just did. Well, x equals -4. I go to my x-axis at -4, put a dot, and I'm going to draw a vertical line through it. And I write the equation. This one is trickier because we can't check it with the calculator. What we can do is take some points on here and write the coordinates. This is -4, -2. This is -4, 1, 2, sorry. This was -4, -3, guys. Sorry about that. Because this is my x-axis. So I went -4 and then 3 down. Okay. This one is -4 and 1, 2, 3, 4, +4. And this last one is -4. I did it again. I am sorry. Starting at the origin. 1, 2, 3, -4, and we went up 3. To get to this one, -4, and we go up 4. But look at our pattern. The x value is always -4. So now, at what point do these lines intersect? So I want to know, when does this x, the y equals -1, intersect with the line x equals -4? If you find it difficult, just follow one of these lines till it touches the other, which is right here. And looking at the origin, we went -4, 4 to the left, and down 1, -1. So they intersect at -4, -1. This is the format of what your test will look like. Please make sure you understand it. If there's any part of it that you still had a little difficulty, please go back and rewatch that. And this has been another SOS video. Take care.